We use these things every single day, right? For pretty much everything. But have you ever really stopped to think about what's going on inside? I mean, with every single click, there's a whole universe of activity happening. So today, that's what we're going to do. We're going to take that journey, dive right in, and explore that invisible world that powers our digital lives, from the actual hardware parts to the secret language they're all speaking.
Okay, so the first thing you've got to get your head around is that a computer, it's not just one thing. It's really more like a team, right? A whole ecosystem with 4 key players that have to work together. You've got the hardware, the physical stuff, the software, the invisible brain, the data it's all crunching, and then, maybe the most important part of all, you, the user.
So let's break down these 4 pillars. Each one is absolutely essential. I mean, if you take away even one of them, that powerful machine on your desk, yeah, it's basically just a very, very expensive paperweight.
All right, first up, hardware. This is the easy one. It's all the stuff you can actually pick up and touch. You know, your screen, your keyboard, your mouse. It's the physical body of the computer, the shell that holds everything else.
Next, we've got the software. And this is kind of like the ghost in the machine, right? You can't touch it, but it's the intelligence behind everything. It's all the programs, all the instructions from your operating system to your web browser. It's the mind of the system, telling the physical hardware exactly what to do.
And then there's us, the users. I know, it sounds super obvious, but think about it. Without someone to actually use it, a computer is completely pointless. You're the one telling it what to do, creating things, asking questions. You give it purpose.
And last but not least, we have data. The best way to think about data is like raw ingredients for a recipe. It's just a bunch of facts, numbers, and text. By itself, it doesn't mean anything. The computer's entire job is to take those raw ingredients and cook them into something useful.
Okay, so now that we've met the whole team, let's get our hands dirty. Well, metaphorically anyway. It's time to peek inside the box and check out the wild world of hardware that makes all of this magic happen.
Whoa. Yeah, that looks complicated. But don't worry, the best way to think about this is like an orchestra. See all those different parts? The CPU, the RAM, the hard drive, each one has its own specific job, but they all have to work together in perfect harmony to get anything done.
So, if it's an orchestra, who's the conductor? Well, that would be the motherboard. This big circuit board is like the central nervous system connecting absolutely everything. The CPU, the memory, the storage, they all plug right into the motherboard so they can talk to each other. It's literally the foundation for the whole system.
Okay, let's zoom in on what is, without a doubt, the single most important piece of the puzzle. We're talking about the brain of the whole operation, the central processing unit. You've probably heard of it, the CPU.
The CPU? It's the boss, period. Every time you click, every key you press, every single instruction from every program, it all funnels through the CPU. It's the part that does all the thinking, all the calculating. It's what actually does the computing in computer. So how in the world does this one little chip do so much, so incredibly fast? Well, it follows this constant, relentless 3-step dance: fetch, decode, execute. It grabs an instruction, figures out what that instruction means, and then it does it. And here's the crazy part. This little dance isn't happening, a few times a second. It's happening billions of times every single second. It's just mind-bending.
Okay, so when the CPU fetches an instruction, where is it fetching it from? This brings us to something that trips a lot of people up: the difference between memory and storage. They sound similar, and they both hold data, but trust me, they work in totally different ways.
Here's the best analogy, and it's a classic for a reason. Think of RAM, or primary memory, as your desk or your workbench. It's where you put everything you're working on right now. It's super fast and easy to grab stuff from, but the second you turn off the power, poof, the workbench is wiped clean. Storage, on the other hand, that's your file cabinet. It's where you put things for long-term safekeeping. It's a little slower to get things out of, but your files are safe and sound even when the computer's off. And it gets a little more detailed, because even on that workbench, there are 2 main types of memory. You've got RAM, which we just talked about. That's for your active programs. But you also have something called ROM, which stands for read-only memory. Now, ROM is special. It holds the super permanent, can't-be-changed instructions that the computer needs just to wake up. It's basically the computer's built-in alarm clock.
All right, we've seen the physical parts, we've met the brain, and we've figured out its memory. For our last stop on this tour, we're going deep, like all the way down to the most fundamental level:
to the secret language that every single one of these parts is speaking.
And here's the big secret, the one that blows my mind every time. At its very core, your computer is surprisingly simple. Every photo on your phone, every song you listen to, every word you're hearing right now, it's all been broken down and translated into a language that only uses 2 digits, a 0 and a 1. That's it. It's called binary.
Each one of those zeros or ones is called a bit. That's the smallest possible piece of data you can have. Just think of it like a tiny little light switch. It's either on, a 1, or it's off, a 0. And from that simple little switch, all of the amazing complexity of our digital world is built. It's incredible. Now, one little bit by itself can't do much, but if you group 8 of them together, you get what's called a byte. And 1 byte, well, that's enough information to represent something we can actually recognize, like a single letter, say the letter A.
So this brings us full circle. The whole point, the entire reason all this hardware exists, the CPU, the memory, all of it, is to take those millions of bits and bytes, which are just raw, meaningless data, and turn them into useful information. It takes a boring list of rainfall numbers for each month and turns it into something you can actually use, like the average rainfall for the whole year. It makes data meaningful.
And there you have it. That's the journey. From a simple on-off switch all the way up to this incredible universe of knowledge and creativity we live in. You know, understanding how this all works isn't just about tech trivia. It's about really, truly understanding the power of the tool that you have right at your fingertips. So, now you know how it all works. The only question left is, what are you going to create with it?